Software projects are complex. Many things can go wrong. These potential problems are called risks. They can cause delays, increase costs, or even make the project fail. Some common software risks include changing requirements. What if the customer wants something different halfway through? Technology issues? What if a new tool doesn't work as expected? Team problems? What if team members don't communicate well or lack skills? These risks can significantly impact a project's success. That's why it's crucial to identify, assess, and manage them proactively. Ignoring risks is like sailing a ship without checking for storms or reefs, a recipe for disaster. The RMMM model provides a structured approach to handling risks. RMMM stands for Risk Mitigation, Monitoring, and Management. It's like a roadmap for navigating the dangerous waters of software development. The model helps teams identify potential risks early on. Then it guides them in creating plans to reduce their impact. By following the RMMM model, software projects can stay on course and avoid costly mistakes. The first step in the RMMM model is identifying potential risks. This involves brainstorming, analyzing project documentation, and talking to experienced team members. It's about asking what-if questions and anticipating potential problems. For example, while developing a mobile app, the team might identify risks like platform compatibility issues, security vulnerabilities, and user interface design flaws. By identifying these risks early, the team can take steps to mitigate them before they become major problems. Section 4. Risk Mitigation, Preventing Problems. Once risks are identified, the next step is to mitigate them. Risk mitigation means taking steps to reduce the likelihood or impact of a risk. It's about being proactive and finding ways to prevent problems before they occur. For instance, to mitigate the risk of platform compatibility issues, the development team can use cross-platform development frameworks, conduct thorough testing on different devices, and consult platform-specific guidelines. By implementing these mitigation strategies, the team can significantly reduce the chances of encountering compatibility issues later in the development process. Section 5. Risk Monitoring and Management, Staying in Control. Risk management doesn't stop at mitigation. Continuous monitoring is essential to track identified risks and assess the effectiveness of mitigation strategies. This involves regularly reviewing the project's progress, tracking identified risks, and identifying any new risks that may emerge. For example, suppose the team monitoring the mobile app development project notices a rise in security vulnerabilities. In that case, they need to reassess the situation, adjust their mitigation strategies, and implement new security measures. Risk management is an ongoing process throughout the software development lifecycle. By actively monitoring and managing risks, teams can adapt to changing circumstances and ensure project success. Section 6. RMM in Action, a Real-World Example and Conclusion. A great example of the RMMM model in action is the development of the Mars rover by NASA. They identified risks like equipment failure, communication issues, and software bugs. To mitigate these risks, they built redundant systems, conducted extensive testing, and developed robust communication protocols. They also continuously monitored the mission and made adjustments as needed. The success of the Mars rover mission highlights the importance of the RMM model in complex software projects. In conclusion, the RMM model provides a structured and proactive approach to managing risks in software development. By identifying, mitigating, monitoring, and managing risks, teams can increase their chances of delivering successful projects on time and within budget.